Welcome to Accurate One. In this video, we're going to dive into the world of machine learning, what it is and how it's applied in real life. We'll also explore 4 key concepts related to machine learning: supervised, unsupervised, semi-supervised, and reinforcement learning. Let's jump right in. Previously, computer scientists had to write extensive lines of code to perform even simple tasks on a computer, like sending a message or performing a calculation. However, as technology advanced, they proposed a groundbreaking idea. What if computers could think like humans and perform these tasks without requiring so much manual programming? This marked the birth of artificial intelligence, AI. The primary goal of AI was to make computers smarter and more capable of handling complex tasks. Within this field, one particular subset quickly gained a lot of attention: machine learning, or ML. Machine learning focuses on finding patterns in structured data and using those patterns to make predictions. For example, it can predict house prices based on historical data, determine the next word in a sentence based on previous words, or group users into categories based on their behavior. Today, ML has countless applications in various fields, from healthcare to finance to entertainment. Before diving deeper into ML, it's important to understand its 4 main approaches, along with their applications. One important approach in machine learning is supervised learning, which is used when working with labeled data. Labeled data means the input and output are clearly defined. For instance, in classifying emails as spam or not spam, the model is trained to predict a specific outcome based on labeled historical data. Supervised learning has practical applications such as filtering spam emails, diagnosing diseases based on patient symptoms in healthcare, and predicting stock prices or detecting fraudulent transactions in finance. In this example, you can see a preview of a data set containing both spam and not spam emails. The first column, index, is simply the order of the emails in the data set. The second column, email, contains the text of each email. This column is our input, which we refer to as X. X is the data that helps us predict the output. The third column, spam, represents our output, referred to as Y. It is labeled as 0 for not spam and 1 for spam. The goal of our machine learning model is to learn from this data set so that when we provide it with a new example email, it can predict whether it's spam or not. We call this predicted value Y hat. We'll dive deeper into these concepts and details in the machine learning course. But for now, let's move on to the next approach. Another approach is unsupervised learning, which deals with data sets without labels. For example, imagine a group of users without predefined categories. Here, the goal is to analyze their behaviors and cluster them into different groups, such as highly engaged users, potential customers, or inactive users. Unsupervised learning is widely applied in customer segmentation to group individuals by purchasing habits, anomaly detection for identifying unusual patterns, like network intrusions, and recommendation systems that group users with similar preferences to provide personalized suggestions, such as on Netflix or Spotify. There is also semi-supervised learning, which combines both labeled and unlabeled data to train the model. This method is particularly useful when labeled data is limited and can enhance the model's performance by leveraging the unlabeled portion. Semi-supervised learning finds applications in image recognition, where a few labeled images guide the model in identifying objects in a broader data set, speech analysis for recognizing patterns with limited labeled samples, and medical research to identify rare diseases by mixing labeled patient records with unlabeled genetic data. Reinforcement learning is a fascinating area where the model learns by interacting with an environment and receiving feedback in the form of rewards or penalties. For example, you can create an environment with rules and place an agent in it to learn how to complete a task. Over time, The agent improves by discovering which actions lead to rewards and which result in penalties. Reinforcement learning has exciting applications, such as training AI to master complex games like chess or Go, teaching robots to assemble parts or navigate obstacles, and enabling self-driving cars to make decisions, such as stopping at a red light or avoiding pedestrians. You can better grasp how machine learning is applied to solve real-world problems. Machine learning isn't just about making predictions, it's about empowering machines to learn and improve from experience, just like humans do. And that's the power of machine learning, teaching machines to think, learn, and make smarter decisions to shape the future of technology and our world. Thank you for watching, and I'll see you in the next video.